Now let's just move on to the further theorem, which says that if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Means we have to show that if we are just talking about a quadrilateral whose opposite sides are actually equal to each other, then we have to prove that it is a parallelogram. So first of all, we know two things about a parallelogram, that in a parallelogram we have the two triangles that are coming after cutting it along its diagonal. The two triangles are actually congruent to each other, and their opposite sides are also equal. So let us suppose if I am just taking these two things together, means those two previous theorems together, and keeping in mind I'm just starting the proof of this one. So let us suppose if I'm just taking the quadrilateral ABCD over here. So as per the question, it is given to us that the opposite sides are actually equal. So let us suppose if I'm just starting with a given condition, that given we have a quadrilateral, ABCD such that AB is equal to DC and AD is equal to BC. This is already given to us. Now what we have to prove over here, we just have to prove over here that the two triangles that we are getting over here, they are nothing but congruent to each other. So hence we just have to prove that the triangle ABC is congruent to the triangle DCA. So if we're able to prove this thing, then as per the properties of the parallelogram, we are done with this concept that the quadrilateral will definitely be a parallelogram. So let's just start the proof of this one. First of all, let us suppose if I'm just talking about this angle, let us suppose this is nothing but my angle 1. Let us suppose if I'm just taking it as angle 1, let us suppose if I'm just taking with the angle 2, let us suppose if I'm just taking this as nothing but angle 3, and let us suppose if I'm just taking it as nothing but angle 4. This is my angle 4. Now as we can see over here, that it is already given to us, that in this particular parallelogram, it is already given to us that in the triangle ABC, and the triangle CDA, and in the triangle CDA we have AD is equal to BC. This is already given to us. Furthermore, we know the thing that AB is equal to DC. It is also given to us. Furthermore, we can see that AC is nothing but is equal to AC, which is nothing but their common arm, which is nothing but their common side, and which implies that by these three things, what can we say about this particular quadrilateral? That if we are just talking about the two triangles, by taking these three conditions, we can say that the triangle ABC is actually congruent to the triangle CDA. It means that they are congruent to each other by SSS congruence criteria. By SSS congruence criteria means all the sides of one triangle, they are actually is equal to all the sides of the other triangle. It implies that they are actually congruent to each other. Now till here we just have proved that the two triangles that we are getting in this particular quadrilateral are actually congruent to each other. But what is our main motive? Our main motive is to prove that ABCD is nothing but a parallelogram. So let us suppose with this I am also just writing that after this thing we have to prove that ABCD is a parallelogram. So this is our actually main motive, that we have to prove that this is nothing but a parallelogram. So since we have proved that these two triangles are congruent to each other, so if they are congruent to each other, then what can we say about these angles? We can say that the angle 1 is nothing but is equal to the angle 4, and furthermore angle 2 is nothing but is equal to the angle 3 by CPCT. Again by CPCT we can say this fact that angle 1 is equal to angle 4 and angle 2 is equal to the angle 3. 3. Now after proving that these angles are actually equal to each other, what we just wanted to prove? We just wanted to prove that the opposite sides are actually parallel to each other. So we can prove this fact definitely. Why or how so? Let us suppose if I'm just talking about these two angles. Since we know that angle 1 is nothing but is equal to angle 4, since angle 1 is nothing but is equal to the angle 4, if angle 1 is equal to the angle 4, it implies that they are alternate interior angle. They are making alternate interior angles which are formed between two parallel lines, and a transversal It implies that AD is nothing but parallel to BC, where AC is a transversal, and with the same concept from the angle 2 and angle 3, what can we say? We can say that we know that since angle 2 is nothing but is equal to the angle 3, it implies that again they are forming a pair of an alternate interior angles which are always formed between the two parallel lines. It implies that DC is nothing but parallel to AB, where AC again is nothing but a transversal, It implies they are alternate interior angles. So hence at the end what we are actually getting at the end that the two sides are actually parallel to each other. Means from this condition and from this condition, what we are getting that AD is nothing but parallel to BC, and further DC is nothing but parallel to AB. And since we are talking about a parallelogram, so we know that in a parallelogram the opposite sides are nothing but parallel to each other, and furthermore we also know that the opposite sides are also equal and parallel. So it implies that ABCD is a parallelogram. ABCD is nothing but a parallelogram that we are getting. So hence this is nothing but the proof of this particular theorem, that if each pair of opposite sides of a quadrilateral is equal, then it is nothing but a parallelogram.